Hello everyone and welcome to this magnification lesson, and in this lesson we're going to learn everything about magnification, from the definitions to some problems that you might get in your IB biology exam. Great, so let's start straight off with the definition of magnification. So magnification, simply put, is basically how much the degree to which something has been enlarged. It's pretty intuitive, it's pretty obvious, but let's just get the official definition down. It's the degree to which the size of an image, so you get a printout of something and it's been blown up by a certain amount of times, that's what the magnification is the degree to which the size of an image, and I'm going to give you some examples, it's going to make so much sense in a couple of minutes, of an image is larger than the image size, so then the actual thing is larger than the image size. That is the definition of magnification. You will hear about resolution, another definition. I like to think of resolution as, you take a picture with your phone, it's slightly blurry, you take a picture a little bit zoomed in of something and it's not that clear, and then you take another picture with a better camera and you can see much more clearly. That's the resolution. So it's the degree. I'll give you an example of resolution to which, it's the degree to which it is possible to distinguish between two objects. So you might get a picture of something that's like a nucleus inside a cell, and the one resolution of the one image is less than the resolution of the other. That means that the one image that had less resolution is going to be less clear than the other one. Between two objects, the object in my example was a nucleus, between the two objects that are very close together. So in this example, you might have a nucleus which has a higher resolution than a mitochondria that was sitting right next to it, and the resolution is different between the two. The one has a better resolution or a higher resolution, that one's going to be more clear, that are very close together. So let's just give you an example. This example is not really of two objects, but really just of two images. So you can see the difference in resolution here. If you look at, obviously this image doesn't have a very good resolution, this one's got a better resolution, but if you note the difference between sort of this cell over here and the one down here, that one's got a better resolution. Hope that makes sense. Okay, great. Now let's go on to talk about the main skill involved with magnification. And for me, the main skill is working out the differences between the various measurements needed in magnification. Most of the time, you will get given a number with a unit next to it. Now I'm going to give you the definition of what this unit is. When you see this unit, this is called a micrometer. Now 1 micrometer is the same as 0.001, sorry, let's just get this nice and neat, 0.001 millimeters. So it's 1,000. Think about a ruler. 1 micrometer is 1,000th of 1 millimeter. So think about a millimeter and chop it up 1,000 times. One of those chops is 1 micrometer. So 1 micrometer is very, very small. Now you can get even smaller units, and an even smaller unit than a micrometer is a nanometer. So 1 micrometer is actually 1,000 nanometers. And you can think of it like this. If I had 1 nanometer, that would be 0.001 micrometer. So 1 nanometer is 1,000th of a 1,000th of a millimeter. So you have your millimeter, you chop that up 1,000 times, that's 1 micrometer. You chop it up another 1,000 times, and then you'll get yourself 1 nanometer. So this conversion, this idea of this conversion, is the biggest skill you need in magnification application questions. I've seen questions where they ask you to convert things, and students really struggle with that concept. Obviously, mm means millimeter, as you've seen before. Of course, you can get centimeters as well, and the conversion would be just to be to give you all of these things, 0.0001 centimeters. So you can see we're just sort of dividing by 1,000 here from micrometers to millimeters. And of course, to convert between millimeters and centimeters, you would then divide by another 100. You can see it's just one more zero being added on here. So let's do an example. How much would 5 micrometers, how much would that be in nanometers? Pause the video and give me your answer. How much would it be in nanometers? Good. It would just simply be 5,000 nanometers. How many millimeters would 7 micrometers be? It would be 0.007 millimeters. So these conversion factors are very important, because the question might give you millimeters and ask for the answer in micrometers. You're simply then going to times by 1,000. If they say, okay, well, I'm giving you my answer in, let's say it's like 0.3 micrometers. How much is that in nanometers? Well, we know to get to nanometers, I'm going to times this by 1,000. So it's going to be 1, 2, 3. This is going to be 300 nanometers. So this conversion between these two things is very important to be able to do. I hope that all makes sense. And let's just, some lessons you'll see they show arrows going between here. So you're timesing by 1,000 between micrometers and nanometers. And if you're going backwards towards millimeters, then you are obviously dividing by 1,000. I don't really like these arrows. I always like to say, okay, I memorize 1 micrometer is the same as 1,000 nanometers, and it's the same as 0.001 millimeters. That sort of basic 3 gives me enough information to be able to convert anything. Okay, so that's the first thing we have to start off with this lesson is about converting. And I'll show you some examples where they ask you to convert. Let's move on. Now, we have a special triangle that we need to go and memorize. I like to memorize this triangle with the word aim, A-I-M. And you write it like that. Now, this triangle is used to figure things out when you get given a question. So this I stands for image size. This M stands for magnification. And this A stands for actual size. Okay, great. I'm going to use this triangle to calculate a few examples. I'm going to switch over to a camera which is going to highlight my desk. I hope you are going to be able to see this camera. Just give me 1 second while I get it into place. Okay, brilliant. Here we go. So here's a question, and to do any kind of magnification question that you get in your exam, you're going to need yourself a ruler, get yourself a pencil, and a good old calculator. All 3 things here are very near to me. So let's have a look at this first question. The diagram below is a drawing of an organelle from a ciliated cell as seen with an electron microscope. So here's the length of the cell, and I've got this little figure here saying times 20,000. When you see times 20,000, that is the magnification. So you can fill in on the sheet magnification. When you see this times, it means magnification. Okay, so I've got that down over there. Now let's see what the question's asking. Calculate the actual length. So they're asking for A. So what you do is you put your finger over the thing that they're asking you for, and now you've got a simple equation. I'm going to take the image size and I'm going to divide it by my magnification. I know my magnification is 20,000. So at the bottom of my equation, I've already got 20,000. At the top, my image size, that is what I'm going to use my ruler for. Okay, that's the image size. That's what I'm going to measure with my ruler. Calculate the actual length of the organelle. So it's asking me for the length of this organelle. That's the line AB. So I go and take my ruler. I'm going to try to get this a little bit closer to you. Take my ruler, put 0 on the beginning of this line, and I can see this measures to about 10.2. And that is 10.2 centimeters, which is the same as 102 millimeters. I'm going to use millimeters in this example. Millimeters. You can use centimeters if you want. I just find it easier to convert 102 millimeters to micrometers, because this is what the actual length is measured in. It's measured in micrometers. They haven't asked me. Oh wait, they have. They've said express your answer to the nearest micrometer, UM. So I'm going to convert this now. 102 millimeters is the same as 102,000 micrometers. Remember, 1 millimeter equals 1,000 micrometers. Remember, I started off by saying that 1 micrometer equals 0.001 millimeters. Well, that's the same as 1 millimeter equaling 1,000 micrometers. Okay, so now I've got 102,000 micrometers on top. I've got 20,000, that's my magnification on the bottom. I'm doing I over M, and I'm going to simply just divide these two. So these zeros are going to cancel. 2, 3, and I'm going to type in 102 on my calculator. 102 divided by 20. This is going to give me my answer of 5.1 micrometers. That's the actual length. It's the actual length of the cell. So that's a simple example to start off. When they give you magnification, they always look for what they want. They want the A, they want the actual, so it means we're going to need to measure. Let's do another example where they give us something different. Okay, let's have a look at this example. In this example, the diagram below is of the alveolus together with an associated blood capillary. Okay, let's see what they give us as information of the question. The line AB, that's that line over there, in the diagram represents the actual distance. So they've given me actual distance. Calculate the magnification of the drawing. So I'm going to put my finger over M, and I'm going to need to measure something because I have I over A now. Okay, they want the magnification. So I'm going to find out what the image size is by using my ruler, and I'm going to go and calculate that now. And that looks like it is around about 2 centimeters, which is 20 millimeters. But I like to do it in 20 millimeters. So it's 20 millimeters divided by the actual 1.5 micrometers. I've got a problem. I don't have the same unit, so I need to convert that unit. Remember, I said in the beginning, the most important skill is to be able to convert your different units. How do I convert 20 millimeters into micrometers? Times by 1,000. So 20 millimeters is the same as 20,000 micrometers divided by 1.5 micrometers. I've got the same unit, so I can whack this into my calculator. 20,000 divided by 1.5, and I get my magnification of 13,333. That's my actual magnification. So they haven't put the magnification on a cell, but if they did, it would say something like times 13,333. Okay, simple. Let's go to the next question. Next question says, the diagram below shows the general structure of an animal cell as seen under an electron microscope. Okay, now this question is slightly different. This question is giving me a scale bar. So it's saying wherever you put the scale bar on my diagram, that represents 5 micrometers. So if I just measure this, it's 3 centimeters. Anywhere on this cell that's 3 centimeters, that section there equals 5 micrometers. If I put my ruler over there and I measure 3 centimeters, that section there is 5 micrometers. Okay? So that scale bar is really important to go and measure when they give you a scale bar. So let's go and measure that scale bar now. And I measure my scale bar to equal about 3.1 centimeters. So that's 3.1 centimeters, which is the same as 31 millimeters. Yeah? Okay, cool. Now let's see what they want. Calculate the magnification factor on the diagram. Okay, so magnification factor on this diagram, they're not asking me to specifically measure any specific organelle in the cell. They just want to know what the magnification factor is. So then you use your scale bar. This is effectively your tool that you're going to use to find the magnification. So magnification is going to be my image size, which is the length of this line divided by the actual, which is this number over here. So this is going to be 31 millimeters divided by 5 micrometers. Again, I've got a problem because I have the wrong units on each side of this fraction. So it's going to be 31,000 micrometers over 5 micrometers. Let's go and find out what my magnification is. 31,000 divided by 5. My magnification is 6,200. Okay, so if they didn't put the scale bar, they could have said magnification is 6,200. If they don't give you the magnification, they'll give you the scale bar, and then you can work out by measuring the scale bar with your ruler and dividing that number, making sure to convert to micrometers, dividing by the number that they give you over here. Sometimes this number will be different depending on what microscope they've used, how much they've zoomed in by, so on and so forth. Okay, let's go to a similar question. Again, same question. This time they're asking for calculate the actual length of structure G. So I don't know if you can see on this diagram, but structure G is this structure here. It's a mitochondria. Okay, it's asking for the length of it. So don't measure the width, measure the length. Okay, so now I know if I just do my nice little triangle over here, AIM, calculate the actual length. They want A, so I'm going to divide image size, the exact amount of millimeters of this organelle divided by my magnification. Where do I get my magnification from? Well, I've already worked that out in the previous question. It's 6,200. Okay, so some questions lead into each other. I'm going to go and measure the length of this cell. Looks to be about 10 millimeters. So it's going to be 10 millimeters divided by my, I was just looking at my my triangle again. 10 millimeters divided by 6,200. Remember, when we worked this out, we used micrometers. So we have to convert this to micrometers again. 10,000 divided by 6,200. That will give me the actual length of this cell. 10,000 divided by 6,200, and I get 1.61 micrometers. If they want the answer in nanometers, you simply times this number by 1,000. What is 1.61 micrometers? Remember, 1.61 micrometers is the same as, it's the same as if I divided this by 1,000, I would get it in millimeters. So I just move the decimal place, 1, 2, 3 spots. This is going to be 0.00161 millimeters. That is the actual size of this mitochondria. And if you think about how big 1 millimeter is, think how small this mitochondria is in an actual cell. So So this stuff is really, really small, and this is the whole point of magnification. The whole point of it is to see, okay, well, when we magnify these things, they actually are very, very tiny in our bodies. So it's actually quite amazing. Let's do a couple more. Okay, so we got the same idea here, the diagram below, blah, blah, blah. We've got the same scale factor, which means it's going to be the same magnification. Okay, 6,200 from the first question. Calculate the diameter of the nucleolus, structure B. The nucleolus is the sort of circle within the nucleus. So the diameter, of course, it's a circle. You can measure from side to side, across the middle. And I've got about 6 millimeters there. So again, using my triangle, 6 millimeters divided by 6,200, convert to micrometers times by 1,000, and 6,200, and so we've got 6,000 divided by 6,200. This equals 0.96 micrometers. Okay, so hopefully these skills have helped you in terms of your understanding of what magnification is. Here's one for you to practice. Pause the video and have a go at this one. Okay, great. Again, diameter of the nucleus. I'm just going to get my ruler and measure the diameter of this nucleus. Looks like it's 31 millimeters. Same thing as before, getting pretty easy now. 31,000 divided by 6.2, and this gives me 31,000 divided by 6.2. This gives me 5 micrometers. Okay, now a little bit different. Let's try something slightly different. This question now says, calculate the diameter of the cell at its widest point. In this case, you've got to actually look and think, well, where is the widest point in the cell? And what the widest point in the cell for me would be is if you went across here. This for me is the widest. You will get a little bit of leniency in the exam if you're off by like 1 millimeter or 2, but that will depend. So this for me looks like 103 millimeters, again divided by the magnification. So this is 103,000 micrometers. Write everything out nice and neatly. It's really easy to make a mistake. Divided by 6.2, and this gives me 16.6 micrometers. Okay, great. I hope it's been helpful, and leave a comment if you have any questions.